Okay, today topic we will introduce about the unsupervised learning of the neural network, and we also introduce the best of the deep learning quickly, and then we will discussing with our middle testing question. Okay, and then what is unsupervised learning? Previously we introduced about the supervised learning neural network. Unsupervised learning idea is like the K-means algorithm. K-means means that use the distance to calculate and summarize based on the gravity center. The node more close to which gravity center, it will merge to that group. Also, the neural network and supervised learning use the similar idea. Now, because the supervised and supervised learning, we have label each output node, but unsupervised neural network, we don't label the output. The output just to summarize the similar attribute together. For example, the more general for the digital recognition, our output node from input node to output node. Here is 0, 1, 2, 3, 4, 5, and then last node may be the 9. So this is the output, but we don't understand which pattern need to make it. For example, here input is the trend pattern. So the unsupervised learning also the same idea. We need to have a trend pattern to train a model. After the model set up, then a test pattern input. Then he can understand this pattern is belong to which mnemonic, which number. So the trend pattern, all the trend pattern may be connect to all connection. But sometimes this trend pattern based on maybe the different value input and the initial weight, he will calculate the distance and automatically to group your training pattern to usually if it is balanced, he will mapping your training pattern to the 10 of the output, and then, but for unsupervised learning, we don't have an idea about this is number 0, this is number 1. We just let the training pattern may be mapping to the same output node. That is unsupervised learning. So the more general is more important is this network. We set the coordinate network. Sometimes we also set the set organization map. that is usually used on the cluster by neural network, the SOM, set organization map. Then, based on this, we learn how the cohonal network to finish the data classification. So that is a self-organizing computational map. So let's have introduced about the unsupervised learning. He said the main property of the neural network is an ability to learn from the environment and to improve the performance through the learning. So far, we have considered supervisor and activity learning, learning with an external teacher or supervisor who present a training set to the network. But another type is the unsupervised. In contrast to supervised learning, unsupervised or self-organized learning doesn't require an external teacher, so they don't require an external teacher. During the training session, the neural network receives a number of different input patterns, discover significant features in this pattern, and learn how to classify input data into appropriate category. So unsupervised learning trained to follow the neural biology organized of the brain. Our brain also sometimes is based on the self-organized learning. Because when we see something, but we have no idea or name for this thing. But when we find another thing that is an object that is similar to this object, then we just understand the similar, but no name. Never means maybe you give the name, give the name. So unsupervised learning algorithms are to learn rapidly and can be used and on real time. So have a law, we said Haber law. Haber law is in 1949. Haber proposed one of the key ideas in biology learning, commonly known as Haber law. Haber law states that if a neuron eye is near enough to excite neuron Z repeatedly and partition in its activity, this sympathetic connection between these two neurons is strengthened, and neuron Z became more sensitive to the stimulation from the neuron eye. That his meaning is, for example, here has two neurons. If this neuron is Z, this neuron is I. If this neuron have connection, then he can be active. Maybe some node more close this Z will be a connection too. Like our brain. Our brain have many neurons inside, but you trigger this brain, this neuron. Also will affect the neuron beside this one, And the neuron between this, because it can trigger it, so it can strengthen Strength means that more powerful, that more powerful, because our neuron need to repeat to strength, repeat to. So the Hebrew rule can be referenced in the form of two rules. He said, if two neurons on either side of a connection are active, then the weight of the connection is increased. Active means this node J can be fired. Fire means he can have output. If he can output, then the connection weight can be increased. If two neurons on either side of the connection are active, here is synchronized, here is unsynchronized. Unsynchronized, then the weight of the connection is decreased. Unsynchronized means this one increase, this one will decrease, and then the weight will be decreased. That is Hebrew law. So Hebrew law provides the base of the learning without a teacher. Learning here is a local forming, occur without feedback from the environment. So just forward passing. So happen learning in neural network, we can find that from I to J, if he can, let's say, activity, and then his strength will be increased. That is based on like the protection struct. But when he update the weight, just update the activity weight, other weight are not updated, even decrease, So the Hebrew law, we can express the adjustment of applied to weight at iteration t in the formula. So here, weight ij, that is from the yi, yp, yp, and learning rate, hour. This equation is referred active product rule, because this function is output with input mapping. So if we look the previous network, this node may be this node is YSI, this node is YI, YJ, maybe. So if this test can be active for this node, and he will track because currently your input may be like this one. Here has a signal, other node has no signal input, and here has output, other node no output. So this is the mapping relation from this node mapping to this node. So based on this, he find the path to here, find a path, or maybe need to pass through Ij, and then he increase this way. Okay.
How do we choose the path?
The path. You mean maybe like this also a path. That is based on sometimes you pass through some node, pass through some node. So his idea just this output is increased and mapping to this input. He need to update this path. Update this path. This is famous for the hyperlaw. Hyperlearning that is because that is multi-layer. If only one layer. If only one layer. So from Si to Yi, no hidden. That is directly. So the set organization map. That the network structure is no hidden layer, just from input to output. Hyperlearning implies that weight can only increase to solve the problem. We might impose a limit on growth of the semantic weight. It can be done that introduce a nonlinear forgotten factor into hyperlaw. Forgotten factor is here. Why? Why is a forgotten factor? Previously we said that delta Wij, next time you will update the weight. That is based on this formula. But because sometimes you will decrease some weight or some test, so this is to value to decrease. This is the set, but here is weight Ij, not Si, from J to I, the weight. That he used this, we say a forgotten factor. So forgotten factor usually fall in the interval between 0 and 1. Typically is 0.01 to 0.1 to allow only a light forgotten. Find limit the weight growth. So the deep learning algorithm, we can find set initialize the weight of the network, then compute the neural output at iteration P. P means that maybe the number of the phase, that data training. For example, you have 1,000 training pattern. That after 1,000 pattern input, and then we set a phase. Yp is an iteration, where n is the number of the neural input, and theta j is the threshold value of neural j. And then we can update their weight by next phase. The weight Wij equal P at the delta, this weight, and this weight can be at the punish function also. The weight is correctly defined by generalized active Gaussian rule, and then iteration to finish. Here is an example of how the learning example. For example, we have 4 patterns from S1 to S5, and then initial and final state of the network The initial is the left side. So this type of the network, no hidden, because this is mapping from this one. So 10001 is which pattern we can find from the example 10001. 10001 maybe not in the training. That is maybe a testing or something. S1 is 1, and then he have making the output. He can have an output, and then this one means the network structure enhanced test if the different pattern. That weight also randomly to general. But how to calculate the weight? We just calculate the distance. So here initialize after operation. Now input from S1 find node, output mapping to find node, and then the input output mapping we can become a matrix. After the input layer, input and weight calculation. But why have this value? Because that you generate the weight randomly. And then a test input vector or probe that is defined like this. Now this pattern will be put here, and this is after training model, and then after operation, he can get this result. That means this pattern will cluster to this output. So our neural network usually is to training the weight matrix. Like our testing, we said have what is great descent. Great descent, because this matrix is not big, maybe only 5 by 5. That maybe have 5 features. If the input node is so much that maybe you are hard to use the matrix operation. At this time, we want to find the minimal value. We need to use the great descent to find the answer. So great descent usually use the input node is too much. If too small, we just use the like this. We just use the matrix operation. We can find the solution. So from the helper that means your input will have a mapping output. But extend this, we have a name that is competitive learning. Competitive learning, the output neuron with the competition is called the winner take all neuron. Winner take all. That means, for example, his idea is like this. For example, if this node is the winner, for example, node 2 is winner, so he will update all the nodes go to here. So this weight will be updated. So the weight of, for example, this is the winner node, then this weight will be updated. And then this weight will be updated. This weight will be updated. So all this weight connect to node 2 will be updated. That means the winner will take off, and the other weight has no update. That is idea is based on this. That based on this means next time a pattern like you, like this pattern, and then you will make him to the winner node also. His idea is like this. So that is also famous. We said competitive learning. In competitive learning, neuron compete along themselves to be activity. By hidden learning, several output neurons can be active simultaneously. In competitive learning, only single output neuron is active at any time. That is different idea. So the best idea of competitive learning was introduced in the 1917. So in 1918, the Kohono introduced a special class of artificial neural network called the self-organized feature net. This is very famous until now. There are many papers do the classification, also use this traditional method. These maps are based on the competitive learning. So what is the self-organizing feature map? That means our brain is dominated by several cortex, a very complex structure of billions of neurons and hundreds of billions of synapses. The cortex include areas are respond for different human activity and associated with different sensor input. We can say that each sensor input is mapped to a corresponding area of cerebral cortex. This cortex is a self-organized computation map in the human brain. Like this idea, that is Kohono. Kohono layer, that this type of the neural network also only 2 layers. This is input, this is output. And the output may be a big one. That means the winner collect in which region. For example, here, the winner node is this one. The winner node is this one. And where the weight will be updated, nearby this one. So all this area, the node, all this area, that will be updated, the weight. But far away, this node, we have no response. This Kohono idea. So this one is the winner. But if we use the winner tag one, that means only the winner node weight connect to the winner node can be updated. But Kohono hope to extend the idea. Not only the winner tag all one, the winner neighborhood also can update the value. That is cohonal idea. So the cohonal network model provides a topological mapping. It places a fixed number of input patterns from the input layer into a higher dimension output of cohonal layer. Training in cohonal network begins with the winner neighborhood of a fairly large size. Then as training proceeds, the neighborhood size gradually decreases. Okay. So because we need to understand which node is neighbor the winner node. So the output of the node maybe need to have some relationship. So here, architecture of the cohonal network. That means that from that input signal, output is Y1, Y2, Y3. For example, use 3 nodes. So all the 3 node connection also, connection direct also. So the data connection is used to create competition between neurons. The neuron with the largest activity level among all neurons in the output layer became the winner. The neuron is the only neuron that produces an output signal. The activity of all other neurons is suspended in the competition. Suppressed, that means no response. Maybe he is losing. So the data feedback connection produce an excitationary and inhibitory effect depend on the distance of the winner neuron. This is achieved by a Mexican head function. What is Mexican head function? Like this. This we say the Mexican head function. Mexican head function is like this. This is the inhibitory effect in these 2 areas. This is the excited effect. And connection strength in the middle is the largest. Cohonal network run by shift each way from inactive connection to active one. Only the winner node and its neighbor are allowed to run. If a neuron does not respond to a given input pattern, then running cannot occur in the particular neuron. So their weight update that is based on this. This delta Wij applied to certain weight, that is our Si minus Wij. Wij means from I to J, the node. So if neuron J wins the competition, then he got this delta Wij. If J loses the competition, his update is 0. So that means this. That is, this is Wij, and this is the Si. For example, here Wij is 0.1, 0.1. If Si input is 0.2, and then Si will minus weight, so the delta Wij will be, if our is 0.1, will 0.1 multiplies 0.2 minus 0.1, so that will become this value. So their computation can be finished just based on the input distance with the weight. If here has another node, we said K node, now you also will get a value, which one is the winner, and this will be the Wik, and follow this, you can find delta Wik, and then the value to check which one is the winner node. So the distance of the cohonor, the general use the Euler distance. Euler distance is like this. Usually on the plane only 2 dimensions, but on the data analysis, data set machine learning, that data may be 1,000 dimensions or 100 dimensions. So the number of the n, that is the, in fact, that is the node, how many input node, Now we use this formula to find the distance. So which one is the winner? The distance may be from this node to which node is the shortest. That will be the winner. So if here have for example, here we have 2 nodes. This node is named Si. Like this. And then we can base on this formula to calculate which node is the winner. For example, for this node, Yj, we find the distance of the input pattern. Yk, we also find the distance with this input pattern. And we can find which one is the winner. The winner, then we update his weight. His idea is like this. So identify the winner node is the minimum of the weight distance. So here is an example. For example, there is a pattern input that is 0.52. This we can draw this on the right side. That he has the 2 nodes, S matrix, S1, S2, and he has the weight, the initial weight, W, say, it has Wj initial weight for the maybe the 0.2 and 0.1. It has 3 weight. 3 weight means that he has 3 output nodes. So S1, S2 for this node, maybe this node have a matrix. This node, 3 weight, 3 weight. He want to know which node is the winner from S1, S2. And then, for example, W1 is that from this pattern to the node 1, this one is 0.7, and this one is 0.81, 0.1, and then 2 is the same, from S1 is 0.42, from S2 is 0.7. Also, you can draw this figure, and then you can calculate the distance with this node distance. Now based on the Euler distance, we find this one. So which one is the winner? He said the node 3 is the winner. The winner then update his weight. Only the 1, 3, 1, 3 and 2, 3 can update the weight. This is the cohonal idea. So we update the weight. The update weight W3, only this one. And then we got a new weight, and then repeat to 2. The weight W3 with the neural 3 became the closed input vector as with each iteration. So computer learning algorithm, the complete is like this. We repeat, organize again. You input a pattern, and weight is the initial value. You set up, and then you calculate. This input pattern is more short with which node, based on the Euler distance from the input value calculated with the weight. Weight is randomly generated initial of the program. So you can find which one is winner. The winner then update the weight, and then second pattern input to calculate again, and repeat again. After all the repeated training, the weight will be fixed, and then you input a pattern. You will understand this pattern is more similar to which output node. That is to the clustering, no training, no level, That is unsupervised learning. So this is the previous we have introduced about this idea. So update on the weight, but here is a little different because here we said is 3 output nodes. If the output node can be expand more, for example, and then we extend more node, and then at this time, this pattern not just only connect here, it also connect to all the other nodes, all the other nodes. And this node also connected all the other nodes. And every time you also calculate all the distance this node with others. That became this one. It will become this one is 10. And then you will calculate and find a winner node. For example, the winner node is here. Then his neighbor, you can set a threshold or the radius. Now, for example, one step with this node, one step with this node is also the winner. So one step distance with this node, and then all the node, his weight will be up there also. This is a famous cohonal network. And cohonal network, you need to define this value. This value that we said that the head is neighborhood function. Central around the winner take all neuron, say S at iteration P. So based on this, and then repeat to finish, that we have like this, after this. This is a very famous neural network that for unsupervised learning, cohonal network. Okay, we introduced about cohonal network here. So that is very famous unsupervised learning neural network. Let's take a break. Okay. For this semester, because this day we will have class on other room before, and then so we only have this one and this one only 2 times, only 2 times. So these 2 times, and then this is the vacation, Jordan Board Festival. In fact, it's this day. So the here is also.
But you can choose another one.
So we need to finish the class on 19. Yeah. So our final report must be F student here, F student here. Okay.
So final report is explainable layer and cloud.
Final report is you select the explainable AI. Just do the report.
Okay.
And then in the middle test, some student test not good. We also have 20% if possible. You try to use a plain form that to do machine learning based on neural network. Okay, based on some techniques I miss, or you just use the plain form to do some machine learning work. The plain form you can select by yourself. last time, some students do some image recognition also okay. But just learn by yourself how to use the platform. The general platform that have Microsoft Azure and Google platform or Amazon. I think we just use the free, because if you test data is not big, usually it's free and it give you a period of time. Microsoft for our school student, I think that is free for 1 year, 1 year to use, 1 year to use. Okay. And this, so we only have 3 times, 3 times. And today we think because in this unit we introduce about the neural network, so we just quickly to introduce the idea of the different CNN model only, because that is very popular and important. The CNN is maybe from the AlphaGo. CNN method, in fact, combined with previous, we introduced about the matrix search, matrix tree search, combined with the CNN are applied to the AlphaGo. AlphaGo, the competition also have a paper. You can find it. That you just use the CNN with the matrix research to predict which one will be the winner. So this is about the CNN. So some patterns are much smaller than the whole image. So a neuron does not have the whole image to discover the pattern. Connect to a small region with less parameter. So for example, this pattern here is an attribute, but very small. Very small. But this very small CNN, in fact, CNN model is available for the image, even image have a locate. It can solve it. Why he can solve it? That is based on the mathematical model of CNN. CNN model is he its model is like a matrix. That a matrix, as we know, some matrix attribute. If you make some rotate after the matrix operation, this result will recover it, recover the rotate. That's a mathematical model. But if we introduce that will maybe waste a lot of time for the mathematical model. The pattern appear in different regions. So this bird, his break is here, but this bird is maybe in the middle. So some pattern appear in different regions. This is update bit detector. But this one is middle bit detector. To almost the same thing, they can use the same set of the parameter. That is the CNN hope to solve. So CNN also can do the subsampling. The pixel is not change the object. Subsampling, that means you resize the image, a big one to a small one. So we can subsample the pixel to make image smaller. So the attribute here may be much, but here is a little, but CNN can solve this problem. CNN can solve this type of the image. So the whole CNN operation is by this pattern. This is, for example, this is a cat. And then we enter the convolution. Convolution operation, in fact, that is a matrix operation, mathematical matrix operation. And then we do the math pooling. After math pooling, we repeat the convolution matrix pooling. And then finally, maybe we do the flatten. Flatten means that you let the all node free down. So and then have output. So full connection, free-forward network in last layer. So this is the whole structure of the CNN. But you can set up the convolution and how deep the operation of this area. And flatten usually in that step for traditional CNN model. Maybe now have some modify, but this is the traditional model. So this is mapping to three property. What is the three property? The three property we said, this is the first property. A neuron doesn't have to see the whole image, discover the pattern, because maybe he just only from the small one. And the other is subsample problem. The other is location problem. So based on these three properties, that can map into the convolution to solve. For example, property 1, some patterns are much smaller than whole image. That convolution can map into this property. And convolution also map into the the same pattern appear in different regions. That means that location not relative. And then mass pooling is to the resizing. That means the subsample. So subsample the pixel will not change the object. That is mass pooling mapping work. This is his operation. Now CNN hope to solve these three properties and convolution and mass pooling. Try to mapping to solve the property. So for example, here, this is a convolution operation. Convolution, we usually have a field. And this field, we will mapping a stripe. Stripe means the step. The step, shift a step. For example, based on this field, the first one will operation on this one. The operation is very similar. That you just multiply this field mapping to this area and multiply, and then summarize the result. That is 3. You can find other place is 0. Only this area is 1. So 1, 1, 1 multiplied, summarize is 3. Because stripe is 1, stripe 1 means shift. Now when you use CNN, you can set the parameter. Now shifter here, only this area is 1, but these two areas is 1, 1. So 1, 1 is minus 1, and add this 1. So the result is minus 1. And then the stripe will shift step by step. And then you will find another output. So this is the operation of the convolution. So the convolution field, so we need to try to set up the field. The field cannot be randomly selected. But sometimes based on your feature, and based on you try to filter which kind of pattern. For example, here you try to leave only the diagnose the set value. Other value he hope to remove. Okay. And then this one. So after operation of this, because 3-1 shift this one and shift this one and shift this one is terminal. So stop. So from this field, we can find became this new one. So this new one tell me that these two areas has more higher value. And this is the property 2. Mapping to property 2. Property 2 means that the same pattern appear different region. The idea. So this is the same pattern that appear in different area. And then after this, filter usually not only one. maybe you have a multiple field, like for the color image. Color image is combined with RGB, general. So maybe you filter some color, and then you can define different of the field. For example, this field, this duration, this field fit this duration, this duration, and then the red color, for the red color that he have input pattern, if the image is color, so you can use different and have a different input. So CNN sometimes before the input, you input the parameter of the color is red, and blue, and something, and B. So, and next, we find after the filter. If after filter is like this, like this. After this filter is like this. Then we hope to do the mass pooling. How the mass pooling, the output of this one. I think you have a learning neural network. So someone can tell me what the output of this one. 3. And here.
Because we get the highest value.
And where is this value? 0 and 1
and
3 and this one
maybe
-1. So only select the big one. That is because that's mass pooling. So convolution mass pooling. And mass pooling, after that, we repeat to do this, and convolution and mass pooling. And finally, we do the flatten. Flatten means that you let after the mass pooling, you write down the value, that is the flatten to neural network. After the flatten output, that the last layer usually is a fully connection free wall network. Fully connection. So from this idea, that the AlphaGo use this because it take a picture, take an image, take a picture to get the image of this one, this, and convert it to metric and input to network, and then you have a mass moving. So fully connection free wall network can be used, but CNN perform much better. That the mass move and then he need to, because he's training, he is a supervisor training, so he understand after this move, finally, who will win, because that is learning from the chess book. Chess book have the result, step by step, or the one. So some patterns are much smaller than whole image. AlphaGo sometimes use the 5x5 for first day, and the same pattern appear in different regions. that also the same idea. The mapping of the CNN can solve it. This is the paper. They use the mass pooling, and combine with the neural network and multi-canal research. And also another genre currently we use the reinforcement learning. I think on neural network they also will introduce this one. This one that means reinforce agent learn to take action to maximize its reward. So means that this robot, this agent robot, he do some action, and if he do the right thing, you can get the reward, and then he know this is right. Like we training our dog, cat is more hard to training, dog is more easy, and then if this is error, and then maybe he will be punished. So that is reinforcement learning. So in AlphaGo, the central of the inference learning, that agent learn to take action to maximize his pet reward, and then move next. The result of environment is 3 results. If win, will be a reward is 1. If loss, reward will be -1. If the fail, if the fail that the reward is 0, the result also go to the AlphaGo, and then we observation the result until and next move. So from here, he is do the learning the model, let the model be intelligent. But now the AI, as we let you to do the final report, that is the explainable. Because here is only give the reward, but maybe he don't understand why have the reward. Maybe he just only think he do this thing can reward, but why he do this thing have a reward? That need to be explainable. Also, that is the current highest AI research or neural network research. You need to understand you got this reward is based on which reasoning. That means it is explainable. You can explain. Because I move here, I can hear his 3 number in the next 3 steps. That is why we hope the computer hope he can understand. So this research is very hard. For example, if we reasoning this result by the neuron, we understand why the neuron learning this result. In order to let the neuron understand the result, maybe we need to give the neural network more information, not just only the object, but the object environment also may be need to include. For example, this is a machine working. This is the machine to take the coffee. Why he get the reward? Maybe he work speed, good or not, work pace, or the food on the plane is safe to arrive. So you need to let the machine understand which reason I get the reward. Okay, not just only you do the whole work, get the reward. You need to tell them, after that, have some people walking through you, in front of you, you can stop. So you get a reward, or maybe the reward sometimes is different. Your quality, based on your quality, get the different reward. Okay. So supervised with reinforced learning. The next move maybe 5-5. Next move 3-3. That is supervised learning. Now for inference learning, the first move, many move, you just only get the win. The win. The alpha goal is supervised learning and add the reinforced learning idea. But this time still not explainable. Still not explainable. Okay, this is we just quickly to review that CNN. CNN in fact have a straight mathematical model. Why the location is different, but he can recognize. That is based on the metric operation. Metric we have some norm or norm operation and some attribute. Previous we learned the math or the metric rotator, and after some operation he can recover. He can recover to initial state. That is based on that model. Okay. So now we have let you have a last time test. Today still have a student need to report, right? Last class. And one grand high call.
Have you get to all?
You do.
Bio? One is.
Value is 1 or 2. Vanish.
One is.
Okay, we discussing about how you write. Okay, we discussing about our testing. We have you can add the 20 score 20 score that finish the machine learning on the platform 20 score. And then because one question all students have to finish, so based on your score, I also will add some score for you. That may be this one, and then maybe some question we discuss. For example, the first question is define linguistic variable. Linguistic variable and its value. You need to give the simple example. Now, what is linguistic variable? That is a membership function. Now, be careful. The fuzzy rule. Fuzzy rule include S is high. Then Y is low. Like this. That here need to be the linguistic variable. But both sides need to linguistic variable. We set the fuzzy rule. And then this one is from our. This is from our the PPT file. Most students can finish it for this question. But I think that's no problem. No problem. But this question, because we are open book, so in fact that is hope you can understand how to use the calculator to calculate the value. The question is not hard, but that is for you. You need to calculate the result because we are open book. You need to understand how to use the calculator. For example, here, this question is this question, find, so log, log 50. But the log, the order is how much? Which one? Two. But so you need to how to use the computer to calculator to place. The more problem is this part because here you cannot direct to find it. Maybe need to change the base. To find the result. So how to type this one? How to type this one? We type 51 log, because the calculator usually based on 10. So log 50 and divide log maybe log 2, log 2. You can search and how to press it. And then the next question is the about how to calculate the position recall confused matrix. The question told us that totally have 1,000 image. So student first need to draw the complete matrix first. If complete matrix you cannot draw, you cannot get the correct answer. So the data set is 1,000. And then we said that totally 1,000. That he said that there are 4 images. For example, here is dog, and other is did not say anything. So that is not dog. Not dog. And then the data set had 4,000 image is dog. After user enter the keyword dog, that totally 5,000. For example, here is the real data set. Here is your query. That is predict. Predictor is dog and not dog. So when we predict dog and real, he return how much? 3,000. 3,000. Because he returned 5,000. So have 2,000 is not dog, but you predict he is dog. But in data set, totally he said have 4,000 is dog. So the dog in real data set totally is 4,000. And he said in this image, the image inside the data set, there are 10,000. So here we can find, here have 4,000. 4,000. So this is, you need to list the confused matrix. If you list correct, and then you can find the accuracy. Accuracy means that totally 10,000 and correct dog and you predict is dog. So 3,000 and 4,000 not dog and you predict not dog. So the accuracy is 70%. And then you can find the precision. Precision is for query. You query that the dog you totally return is 500, but only 300 is right. So precision is 30%. And recall is from this side. Because real dog have 4,000, but you only call out 3,000. 3,000. So this is 75%. 75%. And then F1. F1 value is from 2 times. 2 times which one? Precision. Precision and recall. Right? Precision and recall. So you can find the F1 value. Okay? So the confused matrix is important for the machine learning. For the machine learning, we usually use the idea of the confused matrix to do the precision. But this is for the problem is do the classification or clustering. And then the next question, consider the following game tree in which states go. Or first the player, the first player point of view. Assume the first player is the maxima, the player. So A is begin. So from the player 1, he will select the maxima value. And the level 2, level 2. So this one, we select the node, we select the maxima. And this level, we select the node, we select the minimum. And this one, you will select the maxima because this is player. The pen is not work. This is player 1. This player 2. Player 1. Player 2. So he have a question. What move should the first player choose? First player choose is he will choose the maxima. Maxima. But initialize, we cannot understand which one is maxima. So there will be roll down on the button to find. On the button to find, because in this level, he will select the maximum value. Maximum value 3. And here, if not cut, he will select like this. And if this level 1 will be selected. This level X will be selected. If we don't consider cut. And then here, he will select the minima. So here select 3. Here select minima. Here select minima F. So A move where? He moved to D. What moves to the first place? To truth. Because he moved to D, and B will lead him move here. And A will be here. So it's this place. A, B, J, V. He is the best choice. And then one node need to be exempt. If we use our beta algorithm, assume the nodes are exempt from left to right. So when we do this 3 level, that is beta cut off. When we see this 3 level, that is our cut off. For beta cut off is based on the view of B. So B usually hope to find the minima. So when we check this node, he also need to check this node because he don't understand this one is bigger or smaller than it. So for B selection, B will check this node, and he will give here because he will select the minima. So he put 2 here. Put 2 here. So but this level is for A select, he will select 1. And then at here, B check, for him B check. Here have a node F. F is greater than 3, right? F greater than 3. So B will select this node. We will not select this node. But why he not check this one? Because this is checked by node A, P1. P1 will select maximum. So this node at this is F, right? So this node can be cut. We also check this one. This node is 7. But B will select this one. Have a 3 here. So 7 is impossible to be selected. But for A, I at this select this node 7. So this one for B, this one, I need to check because it will select this one. So Q can be cut. Okay? And this level here. This level is another branch different with this one. But here is 1. And here has a 5. 5 for him, he will select 1, not select this one. So this node can be cut. U can be cut. And here also, he select 8. And here he find 10. So this node will be cut. So for the beta cutoff algorithm, O, Q, U, Y will be cut. O, Q, U, Y. But now we are on this level. This level is for A. But for B, he select only minima. A will select maximum. Now we find that we select minimum. 3 will be here. 3 will be put here. And A will be here. A will be here. That 3, 1 is for A level. A level. B also 3. For this level is select 1. This no need to check or not. Because the I also can be cut. I is 5, can cut. Like this. So for him, this X, we try to cut apart, cut this part. So which node can cut? A, 3, 1. A always select the big one. So this is small, at 1. So in fact, 1 is less than 3. So in fact, this node is unnecessary to check. And 8 is greater than 3, so they need to check. For A, need to check. So I can be cut. Our cut off. Because this node is 1. 1 is less than 3. Okay? So I hope is to add this question. Every student add 5 score because no student correct answer. But you know that the game tree idea is just threshold and cut something to reduce the computation. This is not very complex. If a big one, the tree will be very large. If you can cut someone, because after cut this, all the leaf can be removed. Okay, and question 6. Question 6, I am more a little worried. And you? This is a simple question. The 0.2 multiplies 0.20 multiplies 0.5 and add 0.3 multiplies. That is based on Bayesian rule. Because the equation is come from C, so the formula is very simple, very easy. So just only this one. Hey, can you? Yeah. And then, okay, have question about this answer. That is Bayesian rule. Bayesian rule means, this is the whole condition. Whole condition is this, and this is come from the saturation. And this question, this question is previously introduced about the 30 factor. So you need to care that the CF1 is 0.3 multiplies because CFE1 is 0.2, and then this is 0.12. CF2 is equal minus 0.4 multiplies because 2 is this 2, 0.8. So totally is minus 0.32. 0.32. This is the circuit factor. And now we can find two conditions. One is 0.12. Another is minus 0.32. So you apply to this formula, you need to select this one. Select this one. So after select this one, we can find the rule is from this one. But this plate still not work. Maybe put too long. And then so CF1 minus 218. And then 1 minus this abstract minimum. So the result is 4.88 and minus 4.2. This is the result. So the result is minus. And then another question. I think for Chen, Dewi Chen is no problem. And this is the explain. Explain supervisor learning. That is supervisor learning is with data. A star algorithm. Signal style inference. And then that's no problem, I think. And then finally, we have this question. This question is for normalization. We just, because we do the grade descent, we sometimes need to do the data normalization. So here he told us that suppose we want a model that S theta, that is S1 is the median score, S2 is the median score square. This is the square of the S1, S1 square. So the data from here. So sometimes when we do the training, we extend the data. For example, attribute is not enough. That you need to modify the initial attribute to get more attribute for the learning. This like this. The 50 is 10 this feature. And this is final exam. And the question is whether you plan to use post-feature scaling. That is defined by minimum mass or range of the feature and near normalization. What is the normalization feature of the S1 square, S1 square? So the question is normalization feature. S1 square is square. S1 1 is this data. This data. So that if a heap, middle term, 15, and final is 15 in training example. So this question is try to find this item. This item after normalization. But how to do the normalization? How to do the normalization? Because his normalization is which one? Which field? This field. S1 square 2. So he hope normalization this part. Okay? But how we do it? The maximum, he told us, divide by maximum minimum. Maximum is this value. So we get the maximum minus minimum is this one. And then this one and this one, because this normalization, so the maximum minimum divided by maximum minimum, then mere normalization. Here is use the mere. Mere means that you find this one, or you summarize 1 and add 2, 1. Right? And then divide by 4. Because me, we find a me. Value, or maybe between -1 to +1, or 0 to 1. And then another idea is find the data. We usually let the data be log. Log, as we know, the log here is 1,000. 1,000 after log, the value became 3. Became 3. So log operation also one kind of the normalization. That is let the data to be reduced. But after reduced, you sometimes easy to process it and not affected by its value for the training. Okay, so log normalization, you can keep in mind. Sometimes you process data, you can think about this. Okay, but this question also all students cannot finish it. So we add for student as score also. So finally, totally, you can get the score is the list of score at 18, at the 13, okay? At the 5. 5 is for the cut off, 3 cut off. So the last one, I don't know maybe you have no time to finish or not. The last one is a simple question, but student still, many students not finish it, but some are correct. This don't calculation, I think. You just draw the figure. You can understand. Because chemist is calculate the distance. He said S1 is here. S1 0 0. S2 is here. Minus 2. And S3 is here. So he want us to know which the 3 nodes belong to which class. Only 2 classes. One class is located is Q1. Q1 is here. Here is C1. C1 is here. C2 is -1, -1. C2 is here. C2 is here. So from the figure you can find that S3 is close to C1. And S1 is close to C2. And S2 is close to C2. C2 also. So this is only, and another is S1. S1 0. This node also close to this one. So that is just idea. You know the operation of the chemist. You don't need to calculate. You just find the cross point. Okay. Have any question about the testing paper?
I think you forgot to create this number for me. Yeah, you did not create this number.
Okay. Have other student have question? This is why? Confused me.
Yes, this confuse me.
It's correct. Not correct.
Every proposition.
So what? Accuracy.
Position.
Accuracy.
Position operation.
Accuracy.
Position.
Okay, have other questions about your paper? Your answer is here. Okay. And then okay.
Everyone has 13 points. In terms of the yes,
Yeah. So 13. Oh. Okay. Okay, other question. No question, we return the paper. Return the paper. Test paper. And everyone here has the 13. 13. Student at Okay, and then today, maybe today we just only one student can do the report. Okay. Who first? Okay.
I just need a break. I'll go to my school.
We just
The break. I'll just go to the rest.
okay. We wait a moment. Okay.
Actually, this presentation is different from the one.
And speaker, can you mic?
Yeah.
But no battery.
Okay, I'll just speak.
You use the mic.
Mic.
Use the mic.
Okay. So this one is different from the one I have uploaded. This is from the explainable artificial intelligence. So I picked one of those papers from the book shared by Prof. So it's a lesson 2 there. It's about interpretability in intelligent system. So how do we, so I will have an introduction. So mostly in most recent deep learning based neural networks, it's all black box testing. So we give some input and we train the model and then we see the output. So we doesn't know anything what is going on inside the model, what is the features that is being taken to predict the output. So this paper will discuss about different process that is involved in interpretability, and there are different phases like phase 1 was about more of trees that was used to make a decision, and phase 2 is about again about different explainable AI that is being used in neural networks and all. So I'll go through a couple of slides to show you what are the different methods that is being used. So here, so for example, this is like a small example I took from one of the websites. So earlier times when we see that we go to any bank and we ask for a loan, so they simply say that it is denied or it is accepted. We doesn't know on what basis they deny it or accept it. So that is like a local step 1, where they say sometimes it is granted based on their model. They give an input of about our salary, about our previous experience, and the fixed deposit or the savings we have in the bank. And all this comes under the first one. So they just give an input and see that whether our loan is approved or not. So in the model 2, where it is more of explainable, where they give different reasons like age is less than 60, 25, and job is a clerical job, and income is less than 900. So it is denied. So it gives more explanation to the denial of the approval. So that is where we are leading into when it comes to explainable AI. So this is the research paper, Interpretability in Intelligent System, a New Concept by Lars K. Hansen and Laura Ligger. So what are the desiderata? That is what can a modern work learn? What are the goals of this interpretability? So what are the desiderata? It is an Italian name. What is the desiderata? Means desired salient dimensions. So here in this case, the salient dimensions is more of a feature which could be of multiple dimensions, or it could be of a single dimension, 2 dimension, 3 dimension. So that what kind of dimensions that has to be taken for the here. In this case, it says salient dimension, but it's more towards the features. So that should be taken to address any issues. So the important specific challenge of understanding the dimensions of uncertainty in machine learning models and their explanation. So these are the main goals of the modern explainable AI. So we need to understand what are the desired dimensions that has to be fed into those machine learning to get a explainable model and get an output. So the major technique is towards these are the constraints that has been defined in this paper to come up with an explainable AI. So the first one is fidelity. The explanation must be reasonable representation of what the system actually does. The second one is more towards understandability, involves multiple usability factors including terminology, user competencies, level of abstraction and interactivity. And then sufficiency. The first 1 and 2 are more important. Sufficiency should be able to explain function and terminology and be detailed enough to justify decision. And then actually first, second and third plays a major role in explainable AI. And the D1 and D2 are more towards, that's where our knowledge and decision making comes into. And D4 is low construction overhead. The explanation should not dominate the cost of designing AI. And the fifth one is efficiency. The explanation system should not slow down the AI significantly. So this is where the major technique should be involved in. And then the first generation system was characterized by explanation based directly on rules applied by the AI to reach decisions. So there are 2 categories, the first generation and the second generation. And the first is more of rules. The second one is expert system, moved on to important principles, can be learned from Swart and Moore. They came up with the second generation expert system, which from abstract layer to a lot of rules, and then there are, for images, there are different kind of techniques they use to get to know the abstract layer of a model. So first generation system is local interpretable model agnostic explanation. This is couple of Mycin is one of those which we have learned it from our courses. And there is also sparking interest in Gallant and by Craven and Shavel, and also trees are one of the first generation explainable AIs. So in the second generation, we have more of the techniques they use here is like there are backward propagation with neural networks, and also gradient descent is one of the methods they use for getting more explainability of the features that is being involved in creating this model. So let me go a few slides. The first generation system was characterized by explanation based directly on rules applied by artificial intelligence to reach decisions. This leads to high fidelity but often conflicts with understandability, because the rules used for inference may be incomprehensible for the user, because it is not comprehensible for the user. So it is high fidelity, but it cannot be understandable. So in the future, when we have to expand the system, the data scientists or the researchers will not know how to come up with a new rule or the data how it should be applied to create this model. So that is one of the first generation drawbacks. And then local interpretable model agnostic explanation scheme. This was again a first generation model. It's based on image segmentation and random sampling. And here this challenge is with the D5. And so I have listed a couple of systems, that is first generation AI, which have different challenges with respect to the methods, the parameters that is being defined in the previous slide. So second generation AI in certain application domains of neural networks, including scientific and biomedicine. So where do we have, because biomedicine involves a lot of images that has to be interpreted. So second generation AI is very important when we come to the diagnostic of any kind of X-ray or any kind of biomedical images. So that plays a major role. So some of the tools that were developed is, when you see in the third one, the tools developed include 3D mapping of voxel-wise saliency and sensitivity. The usability is neuroscientists, as Prof was talking about, training the brain. The brain map visualizations were further enriched with knowledge graph information to facilitate decision making and teaching. So that is where the future is when it comes to 2D generation AI. So this is like, just to show you an example how the decision, I just created it using a Python code. So first generation is how the trees has been divided into decision, trees has been involved in making a decision making. So Gini index is one of the parameters they use for making the splits for the different, creating a nodes and the splitting of the nodes. So in this case I have a data from X is like two features I have. So this is from, let's say, X1 and X2. So I have these two features. X1 is varies from 0 to 1, and this one X2 is from -4 to 77. And Y is like the output that classifies this data. So I have two classes, A and B. So here is the graph that is being printed out from the Python code. This was using the library, that is the decision tree classifier library from Python. But from looking at this, nobody has a clue what was going on, why is Gini involved and all this, how does it, how do we use, how does it split those branches, all this. So I just came up with a worked out example. So here what happens is, we have variable 1. So first thing is, in the previous slide, we have a data. So usually here we are splitting into two branches. So we'll take the minimum one. Here 31 and -4 are the minimum. So the first one is, variable 1 is equal to 1, and then the variable 2 should be greater than or equal to 32. So that is just by taking into the lowest level. So we are calculating the Gini, that is the formula that is being used. So here 4 by 10 is the number of instances where the 1 is 4 out of 10, and 6 are the instances for 6 out of 10, for 6 out of 10 is for 0. So I have used this formula to come up with this Gini index, that is 0.375 for 1 and then 0.44 for 0, and then Gini index is calculated as 0.41667. So, and then based on this tree is being split. So if you look at it, there is Gini, this one is less than, Gini is 0.469, and the variable should be greater than, so there are 8 samples that has been isolated from there. So there is 5 with 1, and then there are 5 with zeros and 3 with 1. That is what this value is being, the bottom. So we keep calculating it. The next one will be, we'll take as 45.5 as the minimum value, because this 31 and 4 is eliminated. So the median is 45.5. So again, applying this Gini formula, we just go splitting it and then classifying it. So this is what, so some kind of formula which has been applied to understand how the tree has been branched. So this gives us a more understanding, like more like a white box, which we will be able to debug when we add future data to it. So what are the advantages? AI explanations provides built-in visualization capabilities for your image data or any kind of data. When you request an explanation on an image classification model with a visualization configured, you will get the predicted class along with an image overlay showing which pixels or regions contributed to the prediction. So that is more with the images, where we can see what kind of, which pixels has been involved to identifying the images. So limitations are concerning the first desired D1 fidelity of explanation. We need to consider the 2 logical fundamental properties, that is the existence and the uniqueness. How unique is our model is, how unique we could identify the output or predict the output. So considering the many constraints imposed by the desired output, the very existence of satisfactory interpretability scheme is a non-trivial issue. Finding such scheme is a concern of current interpretability engineering literature. First one is epistemic uncertainty, that is the uncertainty in the explainability model. So there are a lot of uncertainty when it comes to the unsupervised learning, because we don't know how the data is. So it is definitely a limitation, because there are a lot of knowledge and the data prediction or mathematical calculation has been devised to come up with a more explanation. So it is definitely a limitation. And then epistemic uncertainty gives rise to multiple competing paradigm of explanability. So definitely when we talk about multidimensionality, then the non-uniqueness, when it comes to 3-dimensional, it is easy to get to a certain feature or certain model, but when it comes to a lot of multidimensionality, there are create large fluctuation in solution. Sample can be conspired, so these are definitely a limitation. So this has to be addressed. So comments, here we focus on 2 specific topics from this legacy that could enrich current interpretability work. So careful, so how do they come up with this paper is careful definition of task via explanation desiderata. Here the paper pointed to rich set of ideas developed. So they came up with a rich set of ideas by reviewing different literature in the explainable expert system field, and careful handling of uncertainty. Here the paper pointed out to the comprehensive workflows for quantification of uncertainty of high-dimensional feature importance map, originally developed in the field of computational neuroimaging. So initially it was more into neuroimaging. Now we see that for everything we are, even for any kind of images, we are planning to bring in the explainable AI. That is the future. So future is here. The explainability is the broader sense has been a key component in several intelligent system community. And the central talent of this paper is that the future work can learn from looking back at this history. The usability D2 for neuroscientists was enhanced by embedding the maps in 3D, anatomically informed navigational tools. For example, the brain map visualization were further enriched with knowledge graph. So after the brain map visualization, that has to be mapped to a graph for more decision making. And then the second one is first desideratum, fidelity of explanation. We need to consider the two logical fundamental properties, that is the existence and uniqueness that I have discussed in the previous slide. So considering the many constraints imposed by the desiderata, the very existence of a satisfactory interpretability scheme is a non-trivial issue for me. So this is definitely a future where many researchers have to be doing some research to come up with the uniqueness or existence of the model, applying explainable AI. So this is some reference I have used.
So your report is for our explainable AI.
No, I have another paper. This is just like that. I was reading it.
But not from here.
Yes.
Okay. But also for the explainable idea.
Yes.
So I have a question. If we find a teacher, how you to understand or explain why the teacher is such output? For example, we tell teacher on this side, we find 4 students stand here, and 2 is computer, and the background is here. So his output is meeting, for example. So how the image to explain that is meeting or something?
So
Do you think?
Yeah, so some of that explainable AI we were looking at is XCOS and some encoder and then image segmentation, which tells us, like, if we look at this image, I have a comment here. So this will give a more of this visualization that which pixels in which regions have been involved for the detection. So probably when we work on the weights, like back propagation, what it does is in the CNN, the weights have been back propagated and recalculated. So based on this, if we want to change the pixels that has been involved in detecting the feature, then probably we could use the back propagation and then recalculate the weight and modify the number of pixels, or the place where the pixels have been involved to identifying the picture can be modified. So that could be something we could look at, back propagation, gradient, applying gradient on the back propagation. All these are couple of methods.
So you missed that first step. We also need to separate to different object areas.
Yeah.
Okay.
Thank you.
Thank you. We still have a remainder student, maybe next time we beginning for you report, okay? Because and to the end of the semester we need to do something is the first one. Please tell me. Also close the computer.
This one is enough.
Okay. So to the final of our class, that we need to report.
This one.
Report.
I think that
Oral report.
I just love it.
Oral report of the last time experience for AI.
Okay.
Another is you try to demo the friend form. AI for machine learning. Operation. I think just only do these two things. We don't have a final paper test. Okay. Just do this thing. Previous we create this for paper 20 for our middle test. But I think because we know paper test, we merge to this. So until the end of class, you finish these two things, it's okay. But next week, because we finish the best neural network, I think that is easy for you. Many of you join the neural network. So we have S5 selective question online on the class, just selected the idea of the neural network. Okay. Next week, 5 question. And next week, the paper report continue. Okay. And next week, we have one time to introduce about the hybrid method. Hybrid method is to combine different the method together to improve, like to combine with the neural network with the genetic algorithm together. How to combine them? Next week, we introduce about it. So the platform you can select by yourself. You guide Google, you use Google platform. That just show toy testing.
So how do you use the
platform? The measure is how to use the platform. Because that is important. So now the many cloud applications, and you need to understand how. Previously have a special issue of the journal. You only just let us to do some machine learning method, but need to be on the cloud. Not in your local home. You need to implement in the cloud applications. Okay. Let's we finish class today. Okay. Thank you.